Hi friends, welcome to my channel. In this video, I want to discuss the previous question papers of RRB JE 2018 notification. Yeah, now upcoming mains exam is there now 2025 RRB JE mains. For this, we are now going to discuss the important questions with full explanation. First question starts. RF signal strength at any point of the cable is measured by. Options are oscilloscope, multimeter, field strength meter, obloscope. Here, the answer is field strength meter. You can say that field strength meter. Field strength meter. The clear explanation regarding the things we will discuss now. Here, oscilloscope is not the correct answer. Why? Because oscilloscope is a type of electronic test instruments you might have studied in your BTech or diploma classes. Oscilloscope gives you the clear picture of the wave, but it cannot give you the field strength. Okay, na? Whereas multimeter means it gives the readings of voltage or current or resistance, but it cannot give the field strength of a given RF signal. Here RF means radio frequency signal. The option is obloscope is also wrong option. Why? Because in obloscope it is a device that generates and sweeps markers to the test and align frequency bands. It has a wide frequency band selection on XY scope to display the circuit's response. This is used for testing and aligning TV receivers. Though, hence, the correct answer is field strength meter for this question. Next question, very very important for RRB JE mains. Technical question. This is from digital electronics subject. You might have studied in the BTech or diploma classes. The question is the number of unused states in a n-bit Johnson counter is. Options are 2 power n minus n, 2 power n minus n, 2n, 2 power n minus 1, 2 power n minus 2n. So, in order to understand this concept, we will go somewhat deeply as shown in the figure. In this video, we want to explain clearly about Johnson counter, which is asking multiple times in the RRB JE mains exam. So here Johnson counter is also a known as creeping counter, is an example of synchronous counter. What do you mean by synchronous counter? Synchronous counter means suppose if CP is a clock. Okay, now that same clock has to be given to the each and every flip-flop as shown in here. See, the clock is given to each and every flip-flop so that that the clock transition will energize the flip-flop as shown at a time. Hence, synchronous. The word synchronous means according to the clock at a time. Suppose the clock is active for positive edge, it will be the positive edge clock, or negative edge means negative edge flip-flops. So this is the called as synchronous counter as shown in the above figure. As seen here, the output of the fourth flip-flop is given as feedback to the D1 of the first flip-flop so that it will form a ring. That is nothing but the output of the fourth flip-flop is complemented. Here you see Q4 bar. It is called as complemented. This complemented is given as a feedback or input to the first counter as shown in the figure. For example, for the input clock at the zeroth state of a clock, let us assume the initial states of all the flip-flop registers is 0, 0, 0, 0 as shown, but the fourth flip-flop, the output of the fourth flip-flop Q4 and Q4 bar, it is a complement of Q4, is nothing but 1. This 1 is given as feedback to the first flip-flop which is nothing but this 1. Okay, na? This becomes 1. So the input to the Johnson counter is nothing but 1 of the first flip-flop. This is the Q1 is the first flip-flop, Q2 is the second flip-flop, Q3 is the third flip-flop, Q4 is the fourth flip-flop. So the next input of the flip-flop, the second pulse of a clock is nothing but 1. Nothing but 1. See here. Here it is 1. So again, once here the feedback is 1. Once again, if the clock is energized, then the first flip-flop output is 1. Second flip-flop output is 0. Third flip-flop output is 0. Fourth output is also 0. But here this will become again complemented of 0. Nothing but 1. So again third clock, if you apply third clock, what will happen? If we apply third clock, this value here from here will be shifted to the next value as shown in figure. See here, here the next flip-flop, the clock if it is energized, okay, suppose clock number 2 is energized synchronously for all the flip-flops at a time, which is called as synchronous counter na. So this is a shift register, that means this value will be shifted to next value next flip-flop, and here this Q2 value is shifted to D3 and so on. So here whenever they are here already, this is the previous values is 1 0 0 0. These all values will be shifted by the next pulse, as this one will become here as 1 and this one will be shifted to here as 1. Hence this is 1 1 0 0. And like that again it will be complemented, again one more one will be generated, again the corresponding values are shifted from one register to another, like this and so on, hence forming a, this is a called a shift register, which is nothing but a Johnson ring counter. Using n-bit Johnson ring counter, it can generate maximum of 2n different states. That means how much? 8 different states. For 4 flip-flops it will form as 8 different states. Suppose if it is a normal one, no? What is the number of positions that are available is generally equal to 2 power n. That means 2 power n equal to 2 power 4 here. We are considered as 4 na. 2 power 4, that means the value should be 16. But because of the complemented output of the fourth flip-flop is taken as input to the first flip-flop, there only 8 outputs are generated as shown here. See, only 8 states are available. 8 have only has arrived in used states. What about the remaining 8? Is nothing but they are unused states. So suppose 4 flip-flops are there. Total number of states is 2 power 4 is 16. But as we see, as the complementary output of the fourth register is given as the input to the first register, leading to only 2n states of used states, that is called as 8. So what about the remaining are unused states, which is nothing but 2 power n minus 2n, which is nothing but 2 power 4 is nothing but 16 minus 2n is nothing but 8. 16 minus 8 is nothing but 8. Hence the answer is 2 power n minus 2n as shown in the figure. Hence the answer is 2 power n minus 2n, as actually the maximum possibilities is any 4 flip-flops is nothing but 2 power 4, which is nothing but 16. But out of them, as we have seen the table, only we got only 8 states as a used state, whereas remaining corresponds to unused state, which is nothing but 2 power 4 minus 2 into 4 is nothing but total is 8. Hence the answer is only 8. Thank you friends. I will come with next video with very clear explanation regarding RRB JEE exam, mains exam. Thank you friends. Bye bye.